Welcome to Team DataFam Tableau User Group meeting number 38. This tug works a little bit differently to others because we cater for the presenter rather than the audience. Always good to have a live audience, but it's always good to capture these presentations from different people around the world, which is why the tugs are always at different times and different days. A live audience is great, but all these tugs are recorded, they're online, and you can actually watch them later on. Throughout the rest of this month, we've still got some TC25 presentations coming up, and tonight we have a Visit Sydney presentation, but you don't have to present at any conference at all. If you are wanting to present something about Tableau, anything about Tableau or mildly Tableau related, please contact me. My email is team.datafam@gmail.com, and we'll find a slot for you. But today we've got Kieran presenting about practical AI using LLMs to unlock deeper insights. Kieran's an analyst who's been working with Tableau for 5 years, give or take now, maybe a little bit more than that, across things like the Data School, NBN, WePro, and a few other places. The floor's yours, Kieran. I'll hand it over and you can take it from here.
And my favorite type of calculation is a window function. So thanks for coming today, everyone, to my presentation on, I suppose what I'm calling it is practical uses of large language models. Starting with this screen, AI hype free zone, just because I think it's sort of important. Like, I think we've all gone to a lot of presentations probably recently on all the different things like agentic and all of this sort of very big topics, all these very big data products. And this isn't that. This hopefully is going to be a bit more grounded today and a little bit more focused around, I suppose, things that hopefully you should be able to take and just act on straight away. So really practical uses that I found for some large language models to hopefully just enhance your data visualizations, maybe in a work setting and maybe just in a personal setting as well. So I'm really just trying to keep it really grounded and just quite simple today in terms of thinking, I guess, a framework for thinking about using large language models for data analysis. So let's get underway. So my first job out of university was working as a broadcast editor at a company called Isentia. So what this involved each day was really reading through hundreds and hundreds of different headlines and like news snippets and summaries of radio interviews and stuff like that, and sending off, basically figuring out what the story was about and sending it off to clients that I thought it would be of interest to help them keep on top of the news. And as you can imagine, that was a lot of news that I was reading on a daily basis. I think the sort of point of this role and why I'm starting here is it goes to this idea of like how for most of up until really recently, this was kind of stuff that we couldn't really do with machines in the same way that computers in the same way that we can with a lot of traditional types of data analysis, with this kind of, if you think about news as unstructured data, just headlines and paragraphs, and you really still needed that human in the middle of it to kind of make sense of it and send it off to different clients or kind of find the patterns in it. And when it comes to thinking about unstructured data more broadly, I'd also made the case that up until now, this has been a real kind of I suppose, what do you call it, a block to being able to really analyze a lot of stuff at scale, analyze social media posts or analyze image data. You, up until really recently, always needed somebody, like an actual human in a room, to be there to classify, to extract information from it, to kind of make sense with what was going on. And, that was both really costly and really time consuming in terms of being able to just basically turn stuff like news headlines into useful analysis. And I think that has sort of limited us as analysts, or has been a thing that's still limited us as analysts. So while we're really used to using products like Tableau to conduct our analysis of, structured data sets that are just rows and columns. We've really not been able to tap into the types of insights easily that are contained in that unstructured data without having someone or to classify that for us, or without doing it ourselves as well. And particularly if that's a personal project, that can often be like we're talking sort of days and weeks that someone might spend classifying news articles or trying to sort of sift through tweets or images to classify the data inside them. Obviously, there are companies that specialize in doing this, but I suppose for the rest of us, the like 99%, when it comes to actually using this type of data in the work that we do or in our personal projects, it's really been below limits. It's been underneath the surface of this ocean. But I think the point of the presentation tonight is about, well, what if for these tasks like feature extraction or sentiment or thematic analysis or object image classification, what if instead of relying on this sort of person in the middle and all that sort of time that it takes to put that into this structured data set, these kind of structured data sets that we can use for our vizzes, for our analysis, we can shift that work to large language models or large vision models. So, this is a way of, I suppose, cutting down or removing that bottleneck that has historically put a lot of this data off limits to us. And then we'll be able to hopefully make some cool vizzes with it, and make some cool dashboards and do some, I suppose, deeper analysis on these things that have historically been off limits. So I'm just going to walk through a few examples. These aren't fully fledged examples, I suppose. I've tried to keep it more high level just to kind of stimulate some thinking about maybe ways that you could use this in your own projects. At the end, I'll show some links to some resources that you could go and experiment by yourself with some of the stuff. But for now, the next few sections are going to be fairly high level and just, I suppose, show what's sort of give you some ways to start thinking about what's possible. So we're going to start with a great one, thematic classification. So imagine that you have done a survey of you own a restaurant and you've done a survey of a bunch of people and you've said, rate how much you like this restaurant on a scale of, let's say, 1 to 5, and then told them to explain the reason you chose that rating. They chose that rating. Well, your data set might look something like this. On one hand, the answer to that first question just is really simple. It's either a 1 or a 5. But the second question, that could be anything really. It's so open-ended, and like I said in that role when I was at Accenture, and then after that when I worked in market research, I would spend a lot of time having to sort of read through and manually classify this kind of information, because it's really easy to create a visualization or create some analysis out of just doing something like grouping the answers to that first question into buckets. But how do you easily take a bunch of data like this on the right hand side and graph it? You really can't. So this is where I'm going to introduce, I suppose, a way of using a large language model to create thematic classifications for you. This was done on a little bit of analysis I did, I think, late last year, maybe it was earlier this year, where we had some feedback from customers, and I just needed a way to sort of quickly group that into buckets for us to kind of get a better sense of what people were saying. And this comes from when I was doing this as a market research. So the first thing that you'd create was something called a code frame. So this would be a list of sort of codes, thinking about that question, why didn't you like this restaurant, or why did you like this restaurant? You've kind of got things like the food was good, the food was bad, the customer service was good, the parking's bad, and you've got an explanation as to what each of those codes means. What I want to do is, instead of giving this to a person to read through and classify row by row, give it to a large language model and say that its role is a researcher that's classifying this open-ended survey responses for reviews of a restaurant. Tell it that the task, give it an explanation of the task to analyze each response and classify it into one or more of the reason groups. And then also say, if it's unable to classify it into an existing group, define a new code pair definition and added that back to the code frame. So this is really, what we would do when I was working in market research and had to manually go through and do this type of work. And let's go for an example. So let's say our fictional person, and Liza, has left this review of the restaurant. Well, if we pose this to an AI or to a large language model, it could identify that the food was consistently delicious and beautifully presented, and that the service was exceptionally well correlated with their needs, and return the food good and the customer service good. And that's something that we'd be able to use, gives us more of a structured way to then examine this data. And this is cool because, large language models understand context. They're able to sort of take this type of instruction and open-ended data, and if we can specify response formats for them to return data to us in. Let's take another example. Our next person, analytic, I think that was meant to be analytic, or analyst maybe, thought the music was overwhelmingly loud. Well, we've told our large language model in its instructions, if it's unable to classify that response into an existing group, to return a new code frame definition. And then we can get it to add something else to the list and just, I suppose, continually iterate through. It's a way of, I suppose, iterating, the way of thinking about iterating through a list of these kind of open-ended classification problems to get to something that we can use for analysis. And then we can get to this endpoint where, okay, great, we've got our chart from that first point of just a 1 to 5, but then also now we've got, some better data that we can visualize to give a bit more context using that open-ended response, classification of those open-ended responses. I'm going to take a bit of a deviation now to talk about two other things that you might have seen sort of flying about when it comes to using large language models. One of them is a parameter that you might have seen, possibly when you've been using ChatGPT, called temperature. And the other one's this idea of this thing called structured outputs. So these are both really helpful when it comes to using large language models for thematic classification. So the first one is temperature. And this is a parameter that you can assign when you call one of the large language models from 0 to 1 that basically tells it how deterministic to be in terms of its output. So if it's set at 0, the temperature value of 0 means the large language model will choose the most probable next word when writing its output. For those of you that I suppose don't quite know how they work yet, I suppose the idea is that with the large language model, it's essentially sort of fancy autocomplete, and the way that it chooses each next word as it's sort of responding to you is by looking at the probabilities of words that come after it. So after X word, there might be 4 or 5 different options that are all quite likely. If you set temperature to 0, it'll choose the most probable word, and anything sort of above that makes it more likely it could choose, something from one of the less probable words. So an example of this is the quick brown fox jumped over the lazy. You'd expect with a temperature of 0 to pick dog, but with 1, it could be dog, it could be cat, it could be human, or it could be Susan. And this is important when it comes to doing your thematic classification using large language models. because of this idea of like determinism and repeatability. So what you'd want, I suppose, ultimately is if you're querying the same large language model with the same instructions and the same, in this instance, like customer review, every time you were to repeat that process, you'd want the same output. So thinking about temperature and setting that to 0 means that, if you should need to do the same analysis again, you would expect to get a deterministic or the same response. The next one is this thing called structured outputs. So there are means of instructing when you say, if you were to use Python to query a large language model with your data that you're trying to classify. It could come back again. It's non-deterministic. It really could come back with that response in like any format. But what structured outputs let you do is define ahead of time the type of output structure that you want. So say if we were to say to a large language model, extract the information from this news article, well, there's a bunch of ways that it could do that. But if we were then also to provide this example of, I want that output, the headline as a string, the subheading as a string, the authors as a list of strings, and the date published using a date time field with a very specific format. It's a way of providing that additional guidance to a large language model when you're doing this kind of classification to get the data back in a way that, again, is consistent, is just is consistent, especially if you're doing, if you want the same response format for multiple, let's say, restaurant reviews or multiple news articles or whatever it is that you're trying to classify. So that's the first example to go through, but there are so many different ways that you could, I suppose, use this framework for all things outside of like thematic classification. You could just do something like this, like structured text extraction, feature extraction. You could ask for, the sort of thematic classification, but also capture some kind of logic, tell it to explain its logic about why it's chosen certain themes if it's classified, to give you some kind of like way to, I don't know, maybe like audit it or at least understand the underlying logic of the classifications. You could ask for both feature extraction and then also thematic classification all at once in the same output, say if you were doing the news article example. So there's a bunch of flexibility to how you would do this kind of text-based classification stuff, feature extraction stuff. The main takeaway, I guess, is, that, it's a way of outputting this data in a structured way that you can repeat over and over again for a bunch of different items in a data set. The next thing I wanted to talk about was image classification. So you've got large language models, which are great, but you've also got large vision models that are great. And like large language models, these have been trained on so much image data that they're really great at understanding the context of images, like at a deep level. And especially if you're just doing some ad hoc analysis, way better than, I suppose, something that I think you can put together yourself. So I thought I'd take a moment just to quickly talk about bus stops. I know I'm from Melbourne. I think we all know that here trams are the far sort of sexier mode of public transport, but I do have a soft spot for bus stops. And why is that? It's sort of like this sort of social justice argument to be made over bus stops, above and beyond being the thing that mainly connects the most vulnerable people in society to public services. Sort of the elderly, young people. Buses are often this really important mode of transport for connecting them from, the place of residence to like essential services, be that supermarkets, post offices, schools. But there's a big problem with bus stops in that they don't always have shelter, and particularly on a really cold winter's day or a really hot summer's day, this can be a real impediment to people using transport, like being connected to these services. There's another problem with that, though, that there's actually, as far as I know, no publicly available data source in Melbourne that tells you which bus stops have bus shelters and which don't, which is like a real gap in public knowledge, and one that I had an idea early this year that I wanted to sort of look at and see if I could correct. So, as we know, there's no publicly available data source on this, but what if I used a large vision model and used Google Maps to basically extract a bunch of pictures of bus shelters in my area, and then just query a large vision model and say, hey, which of these images have bus stops in them, and create this sort of data set that didn't exist. And that was what I did. So I was able to use the Google Images Street View API and OpenAI's ChatGPT 4o mini vision model to basically extract all of the bus stops, images of all the bus stops in my local government area, that's Marybeck, and figure out which of them, had seating and a shaded area, and which ones were pole only. And to be honest, it's pretty shocking. 63% of the ones I was able to classify had no shading available. But I think what was more surprising to me in terms of what I thought was cooler about this was, this is a data set that didn't exist prior to, or didn't exist in a, easily accessible way prior to this, but also that, the speed at which I was able to run this classification, like this, if I would have 4 years ago to think about, I've got this idea, I wouldn't mind getting a view on, where bus stops exist in my area or not. That would have been a sort of weeks-long project, sort of hours each night, going through each image, yes, no, and instead sort of able to pull the images together, query the API, and pull together a dashboard, I think, in sort of a afternoon, and then send that off to some friends that work in climate planning to help them with their campaigning. Awesome vision models. There's lots you can do with that, and a lot of potential to, like I said, just create data sets that don't exist from images. Super quick bonus round. Can't get any hands up at the moment, but hands up maybe on your camera if you've heard of an XMR chart before, and I'll just bring the thing back. Who's heard of an XMR chart? Well, they're a great chart. I'm just, what do you mean you've not read Understanding Variation by Donald Wheeler, Key to Managing Chaos? They're a super cool chart. They're just this awesome chart that's able to sort of use some statistical principles to basically determine random and non-random variance. And I read this book earlier this year and I loved it. And I went to Tableau Public to see if anyone had been able to implement one in Tableau. And I found this great chart that Yuri Fahl had put together that basically nailed the thing perfectly. There was only one problem. When I looked at the calculations, they were so large and self-referential that it was just a real headache to try and sit there and figure out what some of the sort of formulas were doing, and sort of piece together how this whole thing flowed together. But I knew about this cool tool called the Tableau Workbook Analyzer that a great member of the Tableau community has put together. Basically, what it lets you do is upload a Tableau workbook and then do things like extract all of the calculations from it, extract a table, I don't know if this is in here, yep, of how all of the formulas kind of relate to one another as an image. And what I did was fit an image of that at the dashboard, the image of the sort of mapping of the formulas, and the formulas themselves into a multimodal large language model and large vision model. Just I think here I used DeepSeek and was able to pull out some really useful explanations really quickly about just how this like crazy formulas what they were actually doing and how they were actually creating the dashboard that I was looking at, and do that in sort of 15 minutes, and then read through the documentation it generated, rather than spend like an afternoon going through with my like notepad and writing everything out. So just like, there's a use case there, something useful there, particularly if you see stuff on Tableau public that, you really are scratching your head trying to get it to work. And then there's sort of that's great, another practical use of some of these language models. So maybe I'll pause there quickly. I've got another little section just about some of the tools used so far, but maybe I'll pause there and just see if there are any questions and if anyone's got any things.
I can read my question if you like, but when you went onto the large vision model, I don't know if you know the answer, but I was always interested with also large image models. When everyone goes, oh, I've taught this model by feeding it thousands of images. But how do you explain the thousands of images to the model so it knows what it is? Or does it just do that? I don't know.
So I think this goes back to this idea of like maybe thinking about AI, machine learning stuff from like a really practical perspective, like how can we use it now just to do stuff. So I think on the one hand, you've obviously got some great libraries out there that you can use to build custom image classifiers, like a great one like Fast AI library, do that incredibly quickly. But just in terms of in terms of I guess the power and the reason about thinking about maybe, as someone that doesn't necessarily have the time or the dedication to really learn deeply how to do that, the fact that these kind of large vision models exist that have been trained already on, all this data from like OpenAI, from Anthropic, from Google, that we can use like relatively cheaply. I mean, I think that and that are able to kind of work, like that are very functional to when they work, and that costs, like for the bus stops example, I think that was a few hundred bus stops like classify these images, and I think it cost a total of like $2 or something like that to get the labels on all of them. And then I think, well, it just in terms of like headache-free, time solved, and not having to learn, not having to go into the depths to learn how to build an image classification model myself. Like it's a real benefit of the stuff from like a practical perspective.
Yeah. Oh yeah, and people do that with I've watched YouTube videos of Claude and stuff like that, and they go, you do all this work and it costs like 3 cents or $5 or something. It's an amazing benefit. Yeah, pretty good savings. Anyone else?
Questions?
Did you want to move on to your bonus section?
Yeah. Yep, cool. So this is a question that came up at Visit in Sydney on just how to sort of get started using some of these tools, just again straight away kind of thing. If you've got a project that you want to work on, or if you've got a, say, even just a Tableau public viz that you wanted to start using some of this stuff to work on. One of the best ways, honestly, is just sign up for this thing, which is called Google Colab. It's a great free Python-based notebook that Google runs. It lets you, it's like free online Jupyter notebooks thing. So use Python, and then just sign up for your API of choice, OpenAI, Gemini, Claude, which you can save your secret into the notebook and start querying from there. The cool thing that I like about this as well, again, just practically thinking about it from this like really practical perspective, maybe you're not super comfortable. Like the easiest way to interact with these models is using Python, but also maybe right now your Python skills aren't the greatest. One of the cool things that I like about this product, Google Colab with Gemini, is that you can sort of vibe code with it relatively easily. Not in a, hey, build me this whole app from scratch kind of way, but just sort of one cell at a time as you work through a task. So here, for example, I've just got a little notebook together. Up the top, I've got those survey responses from that first section. I've put together that code frame in there, and I've saved my system role, and just say, hey, write me a call to the OpenAI API that uses the system role, code frame, and survey responses above. It queries it and saves those responses in a dictionary for later querying, and boom, it generates the code for you, ready to run. Which is like a great little way to start, I suppose, if you are not super comfortable using Python. Obviously, check the documentation though, if you want to go deeper into this. So this is just the OpenAI documentation on how to use their API if you're querying it, but all the other platforms also have great documentation. To learn how to use structured outputs well in AI workflows, Deep Learning AI has a really good course on, I suppose, how those work. So that's the thing that I mentioned before that tells you, this is how I want my output to look. There are great workbooks online that show you step by step how to do things like image classification. If you've got an idea and you want to take that, you want to apply this to it. Great guides online on how to do that. And I suppose we've had our Q&A. So with that, I will leave it here. I've also written the contents of this presentation up into a blog post, and there's a QR code for that if you'd like to check this out and give it a read. And with that, thanks so much for having me, Chris. It's been a real privilege to present to this tug, given the quality of all the other speakers that we've had on it over the last a year. And thanks everyone for coming as well. I hope you've gotten something out of it, and look forward to seeing what you do.
And it's good for having you as well. It's as I said, it's a mixture of TC25, Visit Sydney, everything else that comes up. I don't care where people actually want to present or what they need to present. It's open to everybody. But there's Kieran's contact details, LinkedIn, Medium, and Tableau Public. And obviously there's been a few links that we've been talking about during the meeting, but I'll put those up on the YouTube page and in the event details as well on the Tableau user group site. Okay, Fast Five. Viraj, I think, is gone. He's not here anymore. But Fast Five is just a nice little section on quick questions, quick answers. There's no right or wrong answer. The reason I mentioned Viraj is I usually use AI to create these questions just to have some, a little bit of human interest at the end. And I always ask people if they want to present, or if they want to submit questions as well. So if you want to submit questions, by all means, go ahead. I can group them up together. Viraj sent in a whole heap. I've been using them over different sessions as well. So if you're ready, you need to be unmuted, Kieran.
Let's go.
So first question is, if my mouse works properly, what was the first chart you ever built in Tableau?
Don't know the first chart I ever built, but I think the first chart I ever struggled to build, had to really look up how to do it. I remember it was for my application to the data school, 5 years ago, and it was how to build a donut chart. So I was like, I've nailed the pie chart, but how do I do the hole in the middle?
Yep, this is that next level up. That's cool. Yep. Mm-hmm. Question 2, do you prefer dashboards that are minimalistic or packed with detail?
I'm a believer on the school of Stephen Few and information dashboard design on this one. Minimalistic and direct.
Yep. Awesome.
Minimal color, super grayscale, maybe just a little bit of highlighting.
Yep. Perfect. Not a problem. And question 3, if Tableau were a person, what would you describe how would you describe their personality?
Oh my God, it just gets deeper. The more you get to know it, the more you realize how little you know about it.
That's good.
So, yeah.
It's always a trick question.
Constantly evolving.
Yep. And is there one color you overuse in your dashboards?
Gray. I've got a lot of feedback on it.
Well, it works sometimes. Maybe all the time. Depends on the dashboard. And finally, what excites you more, cleaning data or visualizing data?
Ooh, I think these days cleaning data has been is scratching the itch for me a little bit more. Just getting real into the gritty of doing data transformation.
Nice. No, good. That was easy. That was 5. So the next TUG meeting is almost in a week's time. So like, 5.5 days, basically. Scott's doing a talk on documenting dashboards, the how, the why, how, and what. Again, it's one meeting. I just put up all the different time slots for all the different time zones for different places around the world. The QR code's there, or just go to the user group website. You've probably gone there to register for this meeting anyway, and register for the next one, and you get notifications and everything as you go along. And this recording, a whole heap of other online tugs all have their recordings on the YouTube channel Team DataFam. And if you don't want to watch YouTube, you can listen to it on Apple or Spotify podcasts. And if anyone wants to present, please email me at team.datafam@gmail.com. We've got some spots coming up in November and December, or I'm quite happy to talk about next year. TC26 will be here sooner than what we think. Some people would use it to prepare for then, or work through their different topics and things as well. But again, thank you, Kieran. I know you were thanking me, but I'm thanking you because it was awesome to actually see it. Good to see how LLMs can bring that unstructured data into a more structured format so we can use it with Tableau.
Yeah, pleasure. Thanks for having us along. And cheers for everyone for sticking around as well. I really appreciate it.
And just in the chat, Andy was saying, is not grey the absence of colour?
Yeah, the question's what colour do you overuse? And yeah, is not grey the absence of colour, but yes.
It's always an interesting argument, is how much colour is too much? Should you use colour? And if you're not using colour, then what do you use instead? And a long time ago, when you used to print out graphs to give to people, and then if you use a lot of colours in graphs and you print them on a black and white printer, you've lost all your colour functionality as well. So what do you do?
Shading and cross-hatching, Chris, that was the solution back in the day, wasn't it?
Well, it was back in the day, but how do you do that in Tableau as well? So things evolve, things change. But yes, I often used to cross-hatch a bar chart, and then you get into Tableau and you go, oh, wait, hang on. But if you follow the philosophy of not printing things out, then you don't need to cross-hatch.
We've got next feature request, bring back cross-hatching.
Well, we have dotted lines now, of course, so we're moving towards that.
We're heading there, yeah. I think cross-hatching is one of those requests that's just almost ignored or thrown in the bin. It's not where they want to go.
I'm quite sure you could find it on the forum somewhere that somebody's raised it at some point in the past 15 years.
Definitely.
No respect for the old ways.
We've got to move on sometimes. But anyway, I think that's the last slide. Yep, I can't go any further. So if there's no more, we'll call it for the night. Kieran can go off, and you're heading for the Melbourne tug now, so that could be just as good.
That's great. Thank you very much, Kieran. Great to see you. Good to see everybody.
Thank you, Kieran.
Awesome. Thanks a lot.
Bye.
Okay, talk to you soon. See ya.